Here you can see the two actions we saw previously. We have one for detecting the faces called jar detect faces. Hey there, and welcome to the Mendix How-Tos. With Mendix World 2021 coming up, I was looking back at some of the old sessions when I stumbled upon one by my friend and colleague Alistair Crawford. In the session, he was using Google's Vision API to automatically detect and blur faces inside of photographs. Naturally, I had to try it out, so let's take a look at the results. Before we start, let's take a moment to make sure we have everything we need. You're going to need Mendix Studio Pro 8 or above. I'm using 8.12 in this example. You will need the Eclipse IDE, which you can get at eclipse.org/downloads. You will need a Google Cloud project set up, which has the Google Vision API enabled on it. You also need to have a service account, which is added to the Google Cloud project and has the role owner. You will also need a JSON access key for this API, which I'll show you how to get now. To get the access key, go to the menu inside of Google's Cloud Platform. Click on I am an admin and go to Service Accounts. Now, you should have a service account added here with the role owner. Open it up, and in the top menu we have keys. Here you can see all the keys we have for this. To create a new one, you can click Add Key, Create New Key. Make sure JSON is selected and click Create. Now, you won't be able to re-download this key later. You'll have to create a new one if you lose this. So make sure it's saved somewhere safe. Now that we have Google Cloud set up, we need to get the project files. You can get them from the GitHub created for this. Click on the code button and download as a zip. Click Save. Next up, we can open up the project by extracting it. Move it to your Mendix directory. And then double click the MPR file to open it in Studio Pro. Once your app is open and you click run, you will notice an error message. This is because the Java actions are failing to compile. This app uses Ivy to automatically manage its dependencies. So we need to use Ivy to make sure our dependencies are there and up to date. To do this, open up the terminal. Copy your project location and then navigate to your project location in the terminal with cd and then paste the file path. Now to run Ivy, we just say run ivy.cmd. It's important to note that if you don't have a Java development kit added to your system variables as a path, this won't work. You can read the written blog accompanying this video for details on how to do this. Wait for it to finish, and that's all we need to do here. Our app should now compile correctly when we click run. Let's take a sneak peek at how it works. On the home page, we have two tabs, Face Detect and Credentials. We need to upload some credentials first. On the Credentials tab, click New. Under File, browse for the API key we saved earlier. Click Save. Now we can navigate back to the Face Detect tab and click New. Under Upload Image, click Browse and upload any photo with some faces in it. After you click Save, you'll see it appear in the list. We can now click on Blur Faces to automatically detect and blur the faces in the image. Pretty cool. So how does this work? Before we check out the Java, let's go to our domain model. Inside the face detection module, you'll see three entities: photo, credential, and face location. Face location is non-persistent because we only need it for a little bit and it doesn't need to be stored when we're done with it. If we go to the home page, we'll see the blur faces button that we clicked is calling a microflow. It's calling ACT process image. If we go into that, we can see we just get the credentials from the database and then we call two Java actions. One for detecting the faces in the image and one for blurring the boxes provided around the faces. If we open up the project in Eclipse, we can inspect the Java actions code. To do this, in Eclipse, go to File, Open Projects from File System, choose Directory, and then browse for your apps folder. Click Select, and then Finish to import it. Expand the project and look in the Java source folder under face detections.actions. Here you can see the two actions we saw previously. We have one for detecting the faces called jar detect faces, and one for blurring the faces called jar_blur boxes. So, how does this work? We can see the code is documented with some comments. Let's go through them to understand what is happening here. First, we're setting up the credentials for Google Vision. We do this using a credential provider class, which is created down below. Next, we convert the photo into a format which is usable by Google Vision. We then set the feature type of the Vision API to be face detection. We then prepare the request for the API using the annotateImageRequest class. We then handle the responses for each face in a for loop. And basically, we get all the information provided for each face, such as the X and Y coordinates, as well as the width and height of the boxes. We then create a new face location object and set the values to it. Finally, we add the face locations to a list and convert them into Mendix objects before returning face locations list as the result. In the next Java action, jar blur boxes, we first read the image from the Mendix object and store it into a buffered image. We then copy the buffered image to a new buffered image and prepare the new one for drawing. Next up, we blur the image by taking 3x3 grid of pixels at a time and blurring them together. We then iterate and blur the sub-images based on the previous location. We do this until the entire face is blurred. The result is then written back to a byte array and stored in a Mendix object before being committed. Finally, we clean up and close before returning true. That's it for now, but if you want more of a challenge, why not try adapting this app to work on something else? Google's Vision API has a bunch of different features, such as landmark and logo recognition, even going so far as to recognize text within images. So what are you waiting for? Go make it.